Given question, determine the position of balls for the system in equilibrium. Assume inclined planes are smooth.
Let us understand given system. There are two balls with weight 100 Newton and 75 Newton placed on inclined surface, which are connected with the help of rod of length L. If we observe, the ball at point D is placed on inclined surface which is making an angle of 30 degree with horizontal, and ball at point E is placed on inclined surface which is making an angle of 60 degree with horizontal. We have to find out angle theta when the system is in equilibrium. We will solve this question by virtual work method. We will give the small displacement to the ball at point D. Then what will happen? Because these two balls are connected with the help of rod, then when this small displacement to the ball at point D is given in upward direction, so I will show here this direction, that is delta S, then by the same amount the ball at point E will move in the opposite direction, that is in the downward direction. Because these two balls are connected with the help of rod of length L. We have to show weight of the ball 100 Newton and 75 Newton in vertically downward direction. Now we will show the new position of these two balls D and E in the diagram. So here this ball D is replaced with the position D dash, that is in the upward direction. So I will show here D dash. And the ball E will move in the downward direction. So I will show here this position of the new position of the ball E dash. So D dash E dash we have to connect with the help of rod of length L. So this is the new position. Now here is the angle theta. So in new position the angle is theta plus delta theta, because here small displacement delta S is given. Now from this triangle DBE we can say that we have to find out the value of DB and value of EB in terms of theta. So how to find out? So we will concentrate on the triangle DBE. So here is 90 degree angle, here is the angle theta. So DB is equal to, so this is nearby to angle theta, so we can say that DB is equal to DE cos of theta. So DE, that means L cos of theta, and EB is equal to, so it is opposite to angle theta, so we can say that it is L sin of theta. Now we have displaced this ball at D as well as ball at E. So small displacement delta is given, and that's why there is the change in angle theta, that is theta plus delta theta. So how we can convert this linear displacement dB and EB into angular displacement? So we will differentiate this term with respect to theta, because dB is equal to L cos theta and EB is equal to L sin theta. So I will write here with differentiating this dB is equal to, now cos theta, that means sin theta. So how we can differentiate? L is constant, so cos theta, that means minus sin theta, so minus L sin theta delta theta. Now in the same way, how we can differentiate this EB? Delta EB is equal to, now L sin theta, that means L cos of theta delta theta. So this is the displacement we have converted into terms of theta and delta theta. Now if we observe, this force is in vertically downward direction, that is 100 Newton and 75 Newton. So we will resolve these forces into two components. So first is parallel to the inclined plane and second one is perpendicular to the inclined plane. So for parallel to the inclined plane, and perpendicular to the inclined plane. So we have to take perpendicular line, and here is the direction. Now how to find out its value? So if we observe horizontal line and this inclined line making an angle 30 degrees. So this is the vertical line and this is the perpendicular line. So here also same angle, that is 30 degree. So its value is 100 cos of 30. And here it is 100 sin of 30. Now in the same way we will resolve this into two components. One component is parallel to the inclined surface and other is perpendicular. So we will take here perpendicular. Now again we have to decide the angle. So angle in between horizontal and inclined surface is 60 degree. So for horizontal surface this is the perpendicular line. So I will mark here. And for this inclined surface this is the perpendicular component. So I will mark here. So angle in between these two perpendicular lines is also same, that is equal to 60 degree. So how we can say that it is 75 cos of 60 and this is 75 sin of 60. The ball at point D is displaced along this inclined surface. So there is no displacement along the line perpendicular to the inclined surface. So we will show here the displacement along this perpendicular direction is equal to 0. Now in the same way for the second inclined surface, the displacement along this perpendicular direction is also equal to 0. So we will show here 0. So we are not going to consider these perpendicular components. Now we will apply the virtual work method. Sign convention is the important part. So the forces which are along the downward direction, that is parallel to the inclined surface but in the downward direction, we will use positive sign. So I will mention here. So here this is the line parallel to the inclined surface. So for this downward direction we will use positive sign. So for the opposite direction, that is the forces which are in upward direction, we will use negative sign. Now in the same way for the second inclined surface, the forces which are along the downward direction. So here also this is the second inclined surface. So we will apply the same rule in the downward direction. So I will show here, this is the downward direction. We have to use same sign, that is positive sign. And the which are in opposite direction, that is in the upward direction, we will use negative sign. So this is the important sign convention. So for downward direction we can either use positive or negative, but for the second opposite direction we have to use the opposite sign. Now we will apply virtual work method. So by virtual work method we have to take force multiplied by displacement. Now we will take here this force 100 sin 30. So it is in the downward direction. So plus 100 sin 30 multiplied by displacement. So displacement for this ball at D, because this force is for the ball at D. So if we observe for this displacement at position D, we have calculated delta dB, and which is equal to minus L sin theta delta theta. So minus sign is already present because here delta S is in the upward direction. So minus sign is already present. So we will take this term as it is, minus L sin theta delta theta. Now we will take next force. So next force is 75 sin 60. So direction is downward. So take positive sign. 75 sin 60 multiplied by displacement. So if we observe displacement for this EB, we have calculated L cos theta delta theta. Now the displacement is in the downward direction, so positive sign. So L cos theta delta theta is equal to 0. Now if we observe the common term is L, then delta theta. Here is L and delta theta. So we can take this common term and transfer to the right hand side. Then it will become 0. Now if you observe, this term is negative and this term is positive. So I will transfer this whole term to the right hand side. Then it will become 100 sin 30 into sin theta. So it is 100 sin 30 into sin theta is equal to 75 sin 60 into cos theta. Now we have to find out angle theta. So theta is this angle. So we have to find out. So I will take sin theta and I will transfer this cos theta to the denominator. So sin by cos theta is equal to tan theta, and this term 100 sin 30 I will transfer to the right hand side. So it will become 75 sin 60 by 100 sin 30 is equal to 1.299, and therefore theta is equal to tan inverse of 1.299, which is equal to 52.4 degree. So this is the angle theta made by this rod DE with this inclined surface AB for the system is in equilibrium.